I'm George Casey, and we're at the RSM Technology Experience Center, and today we're going to talk a little bit about innovation in industrials and manufacturing companies. We're doing this leveraging the Microsoft Dream demo and some advanced technologies around IoT, predictive analytics, computer vision, and augmented reality. Leveraging this set, we're going to use technologies from Microsoft like Azure, Azure Synapse, Azure IoT Hub, augmented reality, and computer vision. So here we have a dashboard, and we've created a digital twin or a digital representation of our shop floor. So drilling in, using IoT sensors on the shop floor, we can get a sense digitally of what's happening. Are there issues? Are there bottlenecks? Are there perhaps choke points or things where we're creating inefficiency in the shop floor? The other thing I can take advantage of is alerting and identify based on either algorithms or predictive analytics where attention may be needed on the shop floor. And in our example, we can see the Fabrication 2 Work Center has a red alert flag. So let's drill in on that. So here's a great example of being able to, from a digital platform, drill right into the equipment that's on the shop floor and understand what's happening in the context of operation. So here we have IoT sensors measuring things like temperature, acceleration or movement along multiple axes, as well as vibration. We can also identify some alerts based on pre-configured parameters that optimize machine performance. Down here in the right corner, we'll see we have maintenance scheduling highlighting some predictive maintenance. So opening this, we can get a sense based on past performance in the training of machine learning models, at what point, what were the signals or conditions prior to failure, and how might we use those in a maintenance schedule to make sure we're taking advantage of that in advance of failure, avoiding downtime. So in this case, we have a recommendation based on a speed variation anomaly that can result in overheating and fire. And the recommendation is within 7 days, we're going to replace the speed controller. So another interesting application of technology in a manufacturing context is the use of augmented reality. So augmented reality, we're thinking of devices like the Microsoft HoloLens, by which I can superimpose a digital layer upon the physical world I'm seeing. One great example of how we might use this in manufacturing is in a maintenance context. So in our example, we have an alert on our work center, and we can drill in and now dispatch a technician to the floor with the HoloLens, and using that digital layer, we can superimpose information about the machine and diagnostic information that would help them address the issue, not only identify where it's happening, but also get corrective action advice on how to respond or how to remedy the issue. So using this where we've kind of created a much more powerful maintenance technician. Another exciting deployment of IoT in the shop floor is through the use of smart cameras and taking advantage of concepts like computer vision. So in our example here in our digital twin, I'm going to switch to a heat map. And so using cameras like this is the Azure Percept Vision module, where we can take data from a video stream and convert that to meaningful insight for a manufacturing supervisor. In this case, we're displaying a heat map of the movement on the shop floor, identifying both speed and congestion to help us understand where efficiencies might be gained. So another exciting application of computer vision on the shop floor is in product quality detection. In this case, we can use a smart camera computer vision module and have the parts as they come off the line or as they're finished be scanned by the camera and use a trained machine learning model to detect defects. So in our example, I can look at anomalies detected on our telemetry data, set that to yes, and get actual pictures or images where there's a defect or a flaw in the final product. So if you imagine both improving the quality of assessment and reducing the time it would take over a human worker being able to schedule that, allow the humans to spend time on more value-added activities than simply scanning or looking at performing a visual inspection on each part. For more information, go to rsmus.com.